Welcome to our channel. In this session, we are going to discuss about double linked list. So this double linked list also comes under linear data structure. What is mean by linear data structure? The elements are organized in a sequential fashion. That is a linear data structure. Now, in a single linked list, each element is represented as a node. A node consists of two parts. One is data, another one is address of the next field. Similarly, in double linked list also, each element is represented as a node. But here, the node is represented with three fields. The middle field specifies data, means the information that we want to store. The right field specifies next, means the address of the next element in the linked list, and the left is pointed as previous, means the address of the before node. That means in a double linked list, we are maintaining address of the next node, at the same time address of the previous node. Coming to one example, how do we represent? Suppose this is one node. Assume the value is 10, some 20, some 30, 40. The address of this node is 1000. The address of this node is 2000. This is 3000. This is 4000. Assume these are four nodes. Suppose if this one is the starting node, I always assume the starting node as the head node. If you want to make this node as the head node, now here what is the previous value? Null. Why? If this is the starting node, for the starting node, the previous means there is no element. So address is null. Here, I am placing address 2000 means after visiting this element, next you are moving to this element. You got my point? Suppose here, if you are placing 3000, so from 20 to move to this element. Suppose here 4000, you are moving to this element, and assume if this is the last node, what is the address? Null. Null. Along with forward direction, each and every node maintains the address of the previous node. Now 2000, this node is coming from 1000, so this 1000 address is placed here. Now, this 3000 is coming from 2000. 2000 address is placed here. Similarly, 3000 address is placed here. You got it? In this way, we are creating a linked list in both forward and backward direction by maintaining the address of the next node and previous node, right? Now, in this session, first we are moving into insertion operation on double linked list. Insertion means we are inserting an element into the linked list. What are the different cases? We are inserting an element at the beginning of the linked list, or insert an element at the end of the linked list, or insert an element at any given position. These are the three possible ways of insertion. Now, we will do each and every insertion. Before inserting an element, what is the first step? Always you need to create a node. Before inserting an element, first you need to create a node. So for this node creation, what are the things you need to specify? Whenever you are creating a node, you need to give the data along with the next field, along with the previous field. You need to initialize all these three fields in double linked list. So for that purpose, I am creating one class. Within the class, I am declaring these variables, and by using constructor, I am initialize the variables. Now we will move practically. Parallelly, I am writing the program. First class. Assume my class name is double linked list. This is the class. Okay. Now within this class, what I am doing? create one more class. Here the name of the class I given as node. Why? This class is used for declaring and initializing the fields of a node. What are the fields of a node? One is data field. Now another one is next field. Next stores the address. So what is the data type? User defined data type class node. The next one is previous. Okay. Declaration is completed. What is the next step? You need to initialize. How do you initialize the parameters? Simple thing, by using the constructor. Initially, what is the value in next? Null. What is the value in previous? Null. But you need to pass the data. Means I have only one parameter, that is data. Now here I will write this dot data is equal to data. Now what is the value in the next and previous? Remember, even though you are not doing any initialization, by default next and previous stores null. Otherwise, if you want, you can do the initialization. Remember, even though you are not doing initialization, that's not a problem. By default, it stores the value null. Like this, one class is created. This is the class for node. This is the class for node. Along with, I am declaring one more name, head. Here I am not assigned any value. That means by default, the value of head is equal to null. The value of head is equal to null. Now, coming to the first method. What is my first method? Public node insert to begin of int data, right? Insert to begin of int data. In this method, what is the first step? Whether you are doing insertion at the beginning or end or at any specific position, the first step is you need to create a node. How do you create a node? Like object only. If this is the class, for this class, we are creating an object. Whenever an object is created, the constructor is executed automatically. So, I given my new name as new node. Okay, new. Observe the syntax. Some data. Observe the syntax. This is a class name. This is object. New class name of data. That means one object is created. Means internally one node is created like this. Internally one node is created like this. What is the name? The name is equal to new node. It has some value and the next field is equal to null. The previous field is equal to null. Now, insert at beginning. What is the case? Beginning means assume initially the list is empty. That means there is no element in the list. Then what happened? Whatever the node you created, this is the starting node. I assumed as head is the starting node. And what is head? Simply I written the statement head is equal to new node. You got my point? Suppose I have A is equal to 5. If I written B is equal to A means B also 5. Yes. Similarly, if the list is empty means no node is available. Whatever the node you created, that is assigned to head. That is assigned to head. Before that, what is the condition? How can you say that the list is empty or not? Simply, if head is equal to null, always remember the first node is termed as head. If head is equal to null means the list is empty, then you are doing this operation. Else means list already consists of some set of elements. Clear? This is the list. What is this one? This is head. Where do you insert? At this position, right? What is the name? New node. Now write down the logic. Here, what you want to do, this new node becomes the first node. Before making that one as the first node, you need to provide the connection like this. This next field consists of this one. So what is the logic? New node dot next is equal to head along with head dot previous is equal to new node. By writing the two statements, a link is established. After that, what you need to do? Head is equal to new node. This node is marked as head. Now, coming to the program, right, step by step. First, if head is equal to null, means there is no node in the linked list. Whatever the node you created, that is the head node. The node you created is the head node. Else means at least one node is already available. At least one node is already available. Now, new node dot next is equal to head. Yes or no? You are placing the new node at the beginning. For that beginning next is equal to head. Head is already available at the first position. Now, head dot previous is equal to new node. By using this first step, the right arrow mark is completed. Because of this step, left arrow mark is completed. After that, you must and should do head is equal to new node. Whatever the node you created, now that is marked as H. Now, once coming out of the else, return head. Coming out of the else, return head. This is the way to insert an element at the beginning of the double linked list. Now, insert at beginning is completed. Now, move to insert at end. So the first condition, again same condition. If head is equal to null means, that is the end of the list. Sorry, head is equal to null means there is no element in the list. Obviously, whatever the node you created, that is the head node. Means if head is equal to null in the sense whether you are doing insertion at the beginning or insertion at the end, both are same. Else means already some list is existed. Assume this is the list. Okay. What is the starting node? Head. What is your aim? You need to insert a node at last. Yes or no? But how do you predict whether this node is last, this node is last, this node is last? Always remember the last node, the next field is null. Based on that condition, I am reaching to the end of the list. How? Initially, I assumed the first node as temp. Remember, it is not allowed to change the head. Head always points the first position. That is the reason what I am doing. Initially, that head is assumed as temp. Now, this next to field I am comparing. If it is equal to null means that is the end. If it is not equal to null means I am moving to the next position. What is the condition? I am repeating this process. So, return inside the loop if the next field is not equal to null. So temp dot next field not equal to null. Then means temp moves to next position. That is the temp moves to next position. The same process repeated. See, here also next not equal to null. Now temp moves to here. Here also next not equal to null. Temp moves to here. Here temp dot next equal to null, the condition fail. We are coming out of the loop. Then what is the procedure now? Simply you are making this connection. How? How do you make that connection? Temp dot next. What is the next? New node. Temp dot next is equal to new node. Now make this connection. What is the left? New node dot previous is equal to temp. New node dot previous is equal to temp. Now the two connections are established. Anyway, by default, this value is null only. Whenever you are creating the node, the value is null only. Clear? Now. So here I am doing insert at the end. Node is created. If head is equal to null, head is the new node. Okay. Now coming to else. In the else block, what you are doing? In the else block, I am writing this one node. I am creating some temporary node and that is marked as head node. And I am repeating the process until end of the list. This is the condition for ending of the list. If temp dot next not equal to null, not equal to null, temp is equal to temp dot next. By using this statement, I am reaching the end of a list. Once you reach the end of a list, now you know the remaining procedure. In the last node, what is the last node right now? Temp. In the last node, the next field, we are assigning new node. You are writing new node. And in the last node, new node dot the previous is equal to temp. New node dot previous is equal to temp. Okay. Once coming out here, return head. Like this, we are doing insertion operation at the end of the linked list. Now, move to third case. What is the third case? Insert an element at the given position. Given position. So, the first case is if position is equal to 0, means you are doing insertion at the beginning. Why I am separately writing this condition? If position is equal to 0 means you no need to check the position. Okay, you no need to write any for loop. If position is equal to 0 means directly you are calling the method insert begin. Here no need to do anything. Now else. Else means position is not equal to 0. Assume like this one list is available. Right? This is the head node. This is position 0, 1, 2, 3, 4, 5. For example, given position number 3. Assume a position number 3. What is the procedure? If you want to insert a node at this position, assume the node is new node. So you know the logic. We need to reach up to this position. You are reaching up to this position. How do you write the logic? For int I is equal to 0, I less than position minus 1, I plus plus, temp is equal to temp dot next. Write the logic. Here previously I written the while loop for reaching the end of a list. Here also exactly the same thing. But here I am reaching up to the position. Before that I assumed temp is equal to head. Now observe. My position is equal to 3. Initially I is equal to 0. 0 less than 3 minus 1, that is 2. Now coming inside the loop, this is initially temp. Inside the loop, temp is equal to temp dot next. Now temp is at this position. Next iteration, I is equal to 1, 1 less than 2. The condition is true. Temp is equal to temp dot next. Now this is temp node. This is temp node. In the next iteration, I is equal to 2, 2 less than 2. The condition fails. If the condition fail means we stop the process. That is, I am reaching the position. Clear? I am reaching the position for insertion. Now, how do you do the insertion operation? What you need to do? Temp dot next becomes the new node. New node dot previous becomes the temp. And this temp dot next is this node. This dot previous is this node. Yes or no? You need to make 4 creations. That is 4 links. Suppose first I return the statement temp dot next is equal to new node. What happened? Whenever you return this statement, this link is formed. Observe, if this link is formed, we lost the address of this node. Why? This node address is available here. Whenever first this statement is written, I lost this address. So that is the reason always perform linking for right side. First to do the linkings at the right side. Okay. Wow. Form the link. What is this node? Actually, this is temp dot next. Yes or no? Previously temp dot next. Now this is assigned to new node dot next. Yes or no? So this arrow mark I am forming. How? New node dot next is equal to, in the next to field, whatever previous next. What is that one? Temp dot next. The first right arrow mark is formed. Now, this link you need to form. How do you get this link? This node is temp dot next. That previous is new node. So new node, temp dot next. Temp dot next means this node. Dot previous means that previous link is equal to new node. The right side two links are formed. Now temp dot next is equal to new node. New node dot previous is equal to temp. You got it? First you need to make right side connections. Why? If you make left side connections, we lost the address of this one. Okay. Inside the for loop, you are checking one more condition while moving. What is the condition? Suppose if I given position is equal to 7. Is it possible or not? Anyway, for loop is repeating, but temp points to null. So that is the reason. While moving, at any point, if temp is equal to null, simply stop the process. Simply stop the process. Clear? Now, I will write down. Okay, right? Now, inside this, first, what is the first step? You need to create a node. New node is equal to new node of some data. So node is created. Now I marked the first node as head node, and anyway that is assigned to temp. What is the first condition? I want to check if position is equal to 0. What I am doing here? I am simply call insert begin. What is the name I given here? Begin. Insert begin of data. Directly I am calling. Directly I am calling. Else means we are not doing insertion at the beginning. In that situation, what you need to do? Simply move to position. For int I is equal to 0, I less than position minus 1, I plus plus. Within the for loop, move the temp pointer. Temp is equal to temp dot next. Right? Parallelly, while moving the temp, I am checking the condition. What is the condition? Whenever temp crosses the position, suppose I have only 0 to 5, but if I want to insert at 7th or 8th position, is it possible? Not possible. That means if at any point, if temp is equal to null, so we are printing one message, system.out.println position not found. Position not found, and I am written null. Once the return statement is executed, the remaining part is not at all executed. Suppose if the if condition fails means, you are doing insertion operation. You are doing insertion operation. Okay, right? Now, for is completed. New node dot next is equal to temp dot next. Whatever the temp next existed, now that is the next node of new node. So right side right link is established. Now temp dot next is the next node. Dot previous is equal to new node. Now the right side left link is also completed. Now temp dot next is equal to new node. The left side right link completed. Finally, new node dot previous is equal to temp. If you observe carefully, once you understand single linked list, then double linked list is very easy. What is the additional thing? Here, additionally, you need to write previous. Whatever existed in the single linked list for the next, here you need to write previous, written head, and close this class. Now clear? Here in the double linked list, I am doing insert begin operation, insert end, and insert at specific position. Now create one class. demo double within the class public static void main string args. Okay. Create an object for which class? This class, double linked list. If you want to access the members, you need to create an object. Yes, double linked list. Some OB is equal to new double linked list of. Now, sorry, along with you need to create one more class. What is the class? Display. Whether you are doing insertions, whatever the operation, finally you need to print. Yes or no? So, display operation. So, how do you do the display operation? Node temp is equal to head, while temp is not equal to null. If the temp value is not equal to null, simply I am printing the data system.out.println temp.data. After printing, temp is equal to temp.next. Simply I am reaching end. Level by level, I am reaching end. This is closing of file method. Okay, now here do the operations carefully. OB dot insert to begin of some 10. First 10 is inserted, right? OB dot insert to begin of 20, insert to begin of 30, and then write OB dot display. Okay, now save the program and then execute. .java, go to the command prompt. Java, C space demo double dot Java. Check any errors are there? No errors. Java space demo double. Observe insertion happened successfully or not. First, what I am doing? First to 10, before that 20, before that 30, insert begin operation is completed successfully. Similarly, now observe, after that I am doing insertion at the end. Now what is the output? 30, 20, 10, 100 and 200. That is the output. Check whether the output is right or wrong. See, 30, 20, 10, 100 and 200. This is the output. Now 0, 1, 2, 3, 4. Now insert an element at position number 3, where that is inserted between 10 and 100. Finally, check that one. OB dot insert to position of, suppose the 400, position number 3, OB dot display. Save and execute. Observe, 30, 0, 1, 2, 3. At third position, 400 is inserted or not? Right? This is the way to do insertions operation in the double linked list. In the next session, we will discuss delete operations in a double linked list. This is the end of today's session. Thank you.